plus 1 uncertain digit. So if we have 2 sig figs, that means that these right here are my 2 sig figs, which means that this one is certain. And that means that that one has to be my uncertain digit. Okay. Number 4 is very similar. Okay, we had 91010. And once again, we have that 0 at the end, which is not significant because there's no decimal. And so there would be 4 sig figs, the last of which will always be the uncertain digit. So the last sig fig is always the uncertain digit. The other ones that gave people problems were numbers 8, 9, and 10, which had scientific notation. 3.4 times 10 to the 4. You actually do not need to do anything with scientific notation in order to count the significant figures. So you do not change it. You could, but it shouldn't affect the number of sig figs anyway. This has 2 sig figs. If I was to write it expanded, I would move my decimal place 1, 2, 3, 4 places. So now I have 3, 4, 0, 0, 0. But because this was 2 sig figs, this also has to be 2 sig figs. So I cannot actually write a decimal at the end here. If I was to write 3, 4, 0, 0, 0 and put a decimal at the end, that would be incorrect. This would be correct, and it has only 2 sig figs. So the easiest thing to do with scientific notation is not to change it into regular notation and try to figure out the sig figs. That's a easy way to make a mistake. Yeah. So if you just leave it and just count them. So for example, in number 9, we have 9.0 times 10 to the minus 3. Here we have a 0 at the end. And so we ask ourselves, is there a decimal? And the answer is yes. And so is it significant? And the answer is yes. So that would be 2 sig figs. 1, 2 sig figs. That's my uncertain digit here. If I did want to write that in standard notation, that's a negative exponent, so I want to make my number smaller, right? Because a negative exponent tells me my number should be small, so I would move my decimal place 1, 2, 3 positions to the left. So I would end up with 0.009. I have to keep that 0 because it is significant. Zeros to the left are never significant, so they are not no sig, not significant. And this one has a decimal yes, significant yes. So 2 sig figs there. Okie dokie. If you are having trouble with that or you would like extra practice, please come see me. I am here all day tomorrow during Flex. And that would be a perfect opportunity to get that cleared up. You also have a quick quiz on SI units and prefixes. My grade 9s just wrote a similar quiz, and I only had like 3 people do really badly, and none of them had actually studied properly. Do you know what I mean? So this is a chance to get, it's mostly just memorization, and it's not too difficult. So as long as you put in the time, you should do well on that. But coming up on Tuesday is scientific notation. Yes? So if you are finding that challenging, tomorrow would be a good time to take a look at back tomorrow during flex, yes, before you head off for the weekend and are potentially confused by things. Next Thursday, there's going to be a quiz on making measurements. And if you're like, my God, there's so many quizzes, it's because I want to make sure you have each skill mastered before we do the whole test. Yes? Alrighty. Today, would we like to start by using a buret, just very briefly, so we can see what it's like? Because it's one thing to say burets measure down, it's another thing to physically see it. Okay. So you are going to get a ring stand, which hopefully you know where those are now. Okay, if you don't, you can ask your classmates. You are going to get a buret clamp. You're going to get a buret, and you will probably, yes you will, also need a beaker and, oh, I lent mine to somebody. You need a funnel, but not this one. Okay, this has a thick end, and if you try to put this on top, it doesn't fit, it's too big, okay? So not this one. These ones should go, there's something that says powder funnels. Sometimes people put them in regular funnels. I try and keep them on the top shelf so people don't accidentally pick the wrong ones, but sometimes they go in the wrong place. So funnel, beaker, buret clamp, and ring stand. The number 0 is at the top, and the number 50 is at the bottom, okay? And the whole point of this device is for me to read the value here, which if I look at it, is about 25 and a half, and I'm going to show you like a little extra thing if you're interested. This fancy piece of equipment, any old piece of paper or a card with a black strip drawn on it. Water is clear and colorless, yes? How about glass? Clear and colorless. So it makes the, what do we call this little scoop that the water makes? It makes it really hard to see, yes. What do we call this little scoop here? That's our meniscus. Do we measure at the top of the meniscus or at the bottom? At the bottom, okay? If my water level, I'll put in a little bit more so it's actually a little bit higher. I'm really too short to do this, yes? So if you are tall, you might be able to do this. If you are short like me, or maybe even a little taller than me, you might want to just bring this down to you in order to do the filling, yes? I'm going to show you how not to fill this the first time, okay? First of all, whenever you fill it, you want the little turny thing to be parallel, okay, or to the floor, perpendicular to the buret. The little turny thing is called a stopcock. I am sorry about the name. That's what it's called. There's nothing I can do about it, okay? That is the stopcock, and it should be perpendicular to the buret. Otherwise, it will be dripping out the bottom while you're trying to fill it, okay? Here's what can happen if you are careless when you are filling. What's happening? It's overflowing. And right now I've got it over top of a sink, so that's nice. And it's water, so it's not going to harm me, yes? But eventually you will be putting things like acids and bases in here, and those things can harm your skin, so you do not want that to happen, right? So rather than just pouring it in, this will actually hold a lot more liquid than the buret if you let it. So just before I refill it, I'm going to show you how to drain it. The fastest way to drain it, how would it be? This way? Is that fastest? No, that's kind of slow. If you want to go faster, just turn it upside down over the sink. And if you want it to go fastest, you will also open this up as you turn it over, and that will get rid of any vacuum effect that might slow the draining down, okay? Anywho, filling it up. Just go slow. Just do a bit at a time, okay? You know, don't do too much at a time, and when you get to near the top, you're going to slow down even further, yes? For today, you do not need to fill it to the top. If you want to, you certainly can, but you don't have to. You need this meniscus to be at the level of your eye, okay? So once again, if I have it here and this is not at my eye level, I would want to bring it down to me, yes? So I'm going to bring it down to me, and I'm going to read this, and we agreed that this was clear and colorless, and the glass is clear and colorless. It makes it hard to see. This is where our magic buret reading card comes in. If you put it behind the buret, okay, and you actually want a tiny gap, if you can, between the buret and the card. So right now the card is touching. I just kind of slide my thumb in between the card and the buret so that there's a tiny gap, okay? See, it's touching. What do? I slide my thumb in between just to give a little gap. No gap, gap, no gap, gap. What do you want? Gap. Another temptation is to put the black line right behind the meniscus. No, you don't want to do that. It doesn't help. What you want is you want the black line to be slightly below the meniscus. Why can I not take this cap off with one hand? Oh my God. I can't even take it off with two hands. There we go. So your black line should be like about here-ish, okay? And what that does is that the meniscus will actually reflect that black back, and it will turn the meniscus so it looks like it's a black color, okay? So we are going to be here. This is where my water is. So I'm going to put the black line somewhat, but just slightly below the water. I'm going to bring it down to my eye level, and I'm going to read it. Okay? You are going to have to decide what the smallest measurement is on here so that you can go one more digit than that. Okay? Right now, I'm just going to call it 21 milliliters. That's not precise enough, but let's just call it 21. Okay? At this point, you are going to write down your initial volume. You're going to record it. And then you're going to just let some drain out. You can do it into the sink, or you can do it into your beeper. Oh, I should show you how this thing works. So the clamp has a screw on it that lets you see how there's like a little gap in there? That's where the ring stand goes, is right in there, and you can tighten it up. You need to make sure that the gap is big enough so it slides down. Okay, You wouldn't believe how many people I see the very first time they do this, and it looks like that, which is not especially stable, okay? I know it's tempting because it's like, oh, that was easy, but no, you really want it to be on here and then tightened up. At this point, to get the buret in, you will simply squeeze these two, slot the buret in, and then let it close back up, okay? So we've got that. I have read my initial volume and I've recorded it. I am going to drip some out, okay? La, 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 la. Just let it go for as long as you want to. Just make sure it doesn't go past the 50 at the bottom. And then you can stop it whenever you want to. Doesn't matter. Record your final volume. Calculate the volume dripped out. And then you're going to put your names on a piece of paper on which you have done this, and you're going to hand it in. This is for comments only, it's not for marks, okay? But you're going to pretend it's for a lab and see if you can remember all the things you need to do for a measurement and that sort of thing. Yes? This is a partner one. If there's the occasional person who wants to do it on their own, that's fine. But I would recommend working in a group of 2 or 3 because we will run out of burets if we try and have each individual person do it. Yes? 1 piece of paper per group is good. Okay? Yeah. So, run free, young chemistry students. And you do not need goggles because it is water. Okay? Don't jab the buret in your eye. Well, you know what? I've been dealing with these for 32 years, so I'm pretty confident with it, yeah. The buret is just in the corner over there on the white thing. Yeah. You sure can. Yeah. I understand. Your reading cards are up here on the desk. I should close that little window so you don't all go blind when you go to get one. Yeah. And if it's at an awkward level to read, bottom. Read at the bottom of the meniscus. When you're done, you can just clean it up and then hand in your whatever sheet of paper you've recorded it on.
I don't need to write the date, right?
It doesn't matter.
Okay.
Yeah. Hi. Yeah. Yeah, that's fine. I'll be back on it. Yeah. Thank you. Just right there is great. Thank you so much. Thank you kindly. It's okay. It's okay. I can read almost anything. I've been doing this for 32 years. No, I haven't. That's wrong. I've been doing chemistry for 32 years. Thank you. Just right here is good. Yeah. You don't have to write how many sick figs there are. I know. I've just been having you do that for practice, but eventually you just write the correct number of sick figs and don't tell me how many there are. Yeah. Sorry. You guys can be done a little quicker if you just dump it out. So folks, once everybody's got their equipment away, we'll be looking at page 46. Yes, I believe we do. Let me check. Yes, there's good. Yes.
Yeah, there's probably going to be some feedback on it.
That's okay. That's okay. That's what it's there for. Let's just check on Teams and see if it's up there. Okay? Because I think that's where I put it. I thought if you would like a printed out copy, I can certainly do that for you, but yeah. We'll see if I manage to put it up there. Sometimes I think I've done something. I'm like, oh yeah, I recall having thought of that, and then I'm like, oh, that didn't happen. Hi. Yeah, you would want to put your units in here. Yep. And then, so this is going to be your mass unit, which is your gram, and your volume unit, which is your milliliters. So this will be grams per milliliter. Okay.
Why do we have this?
Huh? Oh, this was for writing, this first blank was for writing the formula using the quantity symbols first, but yeah. Oh yeah, here's our course outline. Yeah. Over on the left here.
Should I take the secrets or?
We'll talk about that in a little bit. Okay, so don't worry about that just yet. Oh, that's Science 9. That's why it says Science 9. That's my Science 9 team. So we were just, I was asked, do we have a course outline? And the answer is, I believe we do. Let's just double check. Over on the left-hand side of our teams, if you click on course outline, there's nothing here, which means I have not managed to put it up for you guys. I will put it up probably this weekend. Yeah, okay. So my apologies for that. Like I said, I thought I had done it. In my brain, I had put it up. I'd made the thing, and anyway. Yeah, didn't happen. Okay. Yeah. Page 46. So with your partner, what I'd like you to do is I would like you to go through number 1, take a look at all of these and decide which one is the odd one out, which one is different than the others. Page 46. Once you've done number 1, you can look at numbers 2, 3, and 4. Okay? Do you recognize this, Chloe? I always feel bad when people go right from 9 to my grade 11 class because I totally reuse use a lot of things because it's like we need to do little reviews, and I'm like, why reinvent the wheel? Tiana's probably forgotten. You've forgotten that you did this in grade 9 because it's been a while for you, but yeah. Okay, well, we're going to do it right now together. So don't check the almighty answer sheet. Let's try number 1 together. And we are going to learn a little bit of sign language here, okay, because we're going to vote on this. So the letter A, you take your fingers and you put them on your palm, and then you put your thumb to the side. That's the letter A, okay, that's the letter A. Fingers on your palm, thumb touching the side, that's A. B, put your palm up and put your thumb on your palm. Okay, so we have A, and then we have B. C is super easy. Can you guess C? C. Okay, that one's really easy. And then D can be a little tricky. You're going to take your pointer finger and point it upwards, and the other ones are going to make a circle. Okay, so put your pointer finger goes up, and then the rest make a circle, and that's the letter D. And it looks like a D when you look at it, but it looks like a B when you're looking at it from the other way. But if you look at your own, it should look like a D. Okay? So there's A, B, C, and D. And so you get to vote on question number 1. When I say 5, 4, 3, 2, vote, you are going to vote on question number 1. 5, 4, 3, 2, vote. What? You get to vote A, B, C, or D. Oh. You can use your left hand, it's fine. It'll look backwards, but it'll look the same. Okay. Okay, so we have salt, yes. Why did you choose C? It's not an element. Copper, Cu. Gold, Au. Salt, our most famous salt. Does anyone know the formula of our most famous salt? NaCl. That is actually table salt. In fact, any ionic compound is called a salt. So I could actually have potassium nitrate, and that is also a salt. All right, don't worry about that too much. We'll deal with that when we get into compounds, okay? But those are salts. And then sulfur, of course, is S. How many capital letters are in the formula for copper? 1. How many in the formula for gold? 1. How many in the formula for each of these salts? There's 2 and then there's 3. In other words, more than 1, which means you have more than 1 element, yes? And then, of course, this one just has 1 capital letter, so it's 1 element. All right, we're going to vote on question 2. So remember, your options are A, B, C, or D. 5, 4, 3, 2, vote. I got some A's, I got some B's, I got some C's. Okay, so we have lots of choice here. Okay, I even saw a D or 2 out there. Rust. Rust is actually iron oxide. So it is Fe2O3. Is that an element or is it a compound? That is a compound. It is made of 2 elements. Can you tell me if it is an ionic compound or a covalent compound? Check with your partner, see if you remember. Okay, what kind of an element is iron? Iron is a what kind of element? Metal. So we have iron, which is a metal, and we're putting it together with oxygen, and oxygen is a non-metal. And if you're a little foggy on where all those are, don't worry, we have a whole unit on that in Unit 3. However, all the blue ones on that periodic table are metals. Okay, all the blue ones. All the purple ones are metalloids, and all the pink ones are non-metals. And iron is kind of in the middle of the blue section, and oxygen's up on the top right-ish area. Okay? So we have a metal and a non-metal, and that gives us an ionic compound. Silver, just Ag, okay? Single element. Water, do we know the formula for water? H2O. Is that an element or is that a compound? That's a compound. And what kind of a compound is that? Is it ionic? No, because hydrogen is not a metal. We have a non-metal. It can sometimes give away its electron, but hydrogen is kind of is defined as a non-metal, but it can give away its electron because it is so tiny. It's only got that one electron and the one electron shell. It behaves in a way that no other element does, so it kind of is in its own little world. Okay, so it's a non-metal plus a non-metal, so that is a covalent compound. Woo! Covalent compound. And wood, no, it's going to be made of some amount of carbon. So I'm just going to put CX, hydrogen, and oxygen. I don't know which ones. There might be a little sulfur in there or nitrogen, but those are the three main elements. Those are the elements you usually find in organic compounds. So organic substances, like your body is organic, the wood is organic, right? They will contain usually carbon and hydrogen and often oxygen. So you guys who said B was the odd one out because all of the rest of those are compounds, whereas silver is the element. Helium, He. Oxygen, do you guys know the formula for oxygen? It's O2. Do you remember the 7 diatomic elements? So if you can't remember the 7 diatomic elements, you are going to ask Dr. Brinkelhoff because he knows the answer, or she. Who knows the answer? Dr. Brinkelhoff. Who knows the answer? Dr. Brinkelhoff. Who knows the answer? Dr. Brinkelhoff. Now, if you don't like that way of remembering it, there are 2 other ways, at least 2 other ways. Okay, there is the hockey stick and the puck, which actually I'll pull up this one because I've got a periodic table here. Okay. Now, if we look at Brinkelhoff, how many elements are there in that? 1, 2, 3, 4, 5, 6, 7. Yes? So I would like you to go to, we're going to go to element number 7 on the periodic table. Yes? There it is right there. And if you start on element number 7 and you draw the number 7, but then you go, hang on, that's only 1, 2, 3, 4, 5, 6. So that's our hockey stick. And what do you need with a hockey stick? You need a puck. So that's the hockey stick and puck. You start on number 7, you draw a 7, and then that's your hockey stick, and then your puck is the hydrogen. Okay, so that's another way that you could remember your 7 diatomic elements. If none of those is working for you, let me go back here so it's actually on our notes and not on some random thing over here. Have no fear. Yes. Have no fear of ice. And then for the last 2, you have to have 2 letters in there. Okay, because sometimes people hear cold and they think carbon or cobalt. It's not carbon or cobalt, it is chlorine. But if you remember your hockey stick and puck, you will find there is no carbon or cobalt in the hockey stick. Okay, it's chlorine. So of ice, cold, here. And again, that's not boron, it's bromine. Okay? And if that wasn't enough, the way I remembered it was in high school, was I just did a little cheer because I was like, I was never a cheerleader, never. No, that was the other one. H-O-N, halogen. Yes? Because you have hydrogen, nitrogen, oxygen, and then you have the halogens, and that rhymes, H-O-N, halogen. So hopefully one of those will stick for you. This is not probably required on this test, but it will be coming up. So we will review these as we go along. Okay, so that's O2, and that's why it's O2. You'll notice in a compound, it's not O2, it can be O3. The diatomic elements are only diatomic when they are partnered up with another of their own kind. Okay, they can do anything they want when they're in a compound. All right. Plastic, it's another C something, H something, O something. We don't know. And then we have potassium. Who's the odd one out? Plastic. Excellent. And how about in our last row? Sand. Sand is actually silicon dioxide, SiO2. Okay. Carbon obviously is C. Bromine, and bromine would be Br2 because Brinkelhoff, yes? And then we have magnesium. Brinkelhoff. There are many different materials in the world, but only around 100 elements, even though we've had more discovered since then. It's so funny, our biology teacher came, we had a new biology teacher come in a couple years ago, and he was like, oh, I have this terrible periodic table that's missing all the elements at the end. And all the chemistry teachers were like, and who cares? Because those elements at the end are ones that have only been created in like particle colliders. So it's not like you could actually do chemistry with them in the lab. So we don't worry about them. Okay, they're good for particle physicists, those last ones. But for us, it doesn't really matter. These elements can be combined in many different ways to make thousands of different compounds. An element is a substance made up of only one type. I should put two blanks there, but oh well. One type of atom. So here we have copper. It's made only of copper. Carbon is made only of carbon. And helium is made only of helium atoms. So those are all elements. Molecules. Sometimes atoms of some elements join together. When atoms join together, what do we say has happened to them? They have, what has formed? When two atoms join together, starts with a B, they have bonded. Okay, so when they join together, when they bond, they can form molecules. One of the elements that exists like this is hydrogen. Each hydrogen joins up with another atom to make a hydrogen molecule. The formula for the hydrogen molecule is H2. Oh, we're just repeating stuff. I should not have given away the game earlier, but that's okay. Since the hydrogen molecule is made of two atoms, it is called a what kind of molecule? Diatomic. Di means two. Other elements such as nitrogen, oxygen, chlorine, iodine, fluorine, and bromine also exist as diatomic molecules, and each diatomic molecule contains two atoms. And the formulas for these are, I'm going to let you write them down because you should know them now. Yeah, I don't know what's going on up there. Mystery. I think they were fixing something and then just gave up. Okay, hopefully you guys got Brinkelhoff or some other ordering of those. These are molecules which are elements because all the atoms in those molecules are the same. However, you can combine two or more different elements to react in a chemical reaction, and then the atoms don't just mix together, they become joined. What does that mean? They bond to one another to make a molecule. So we could have some hydrogen molecules, an oxygen molecule, and we will make two water molecules. So we're taking two elements and creating a compound. Yes? This element, though, is made of molecules. This element is a molecule. And the compound water is also made of molecules. So do molecules have to be compounds? No. Okay. So if I ask you, are all molecules compounds, your answer would be no. Sometimes we have molecules of elements. Okay? In a chemical reaction, the atoms become joined together in different ways, and this is how new compounds are formed. A compound has to have two or more different elements, okay, that are bonded together. Here's some molecules of compounds. Our covalent compounds exist as molecules. If it's covalent, remind me what kinds of elements are in there. Non-metals. Remind me, if you remember, actually remind your partner, if either of you remember, what happens to the electrons in a covalent bond? I understand. That's why we were. It is one of the weaknesses of the semester system. Can you imagine if you had chemistry next semester? You'd be like, I don't remember. Like, I mean, you don't remember anything now. It's even worse, right? Electrons are, what happens to them? They are shared. Okay? They're shared. And they are made exclusively of nonmetals. So here we have a glass of water, and it's got little water molecules floating around it. Water always looks a little bit like Mickey Mouse, okay? Has that distinctive shape with the two ears. Carbon dioxide, on the other hand, is a linear molecule. It actually forms a straight line. And you can see you've got the C's and the O's. Okay, do they actually look like different colors on your black and white paper? Not really, but they say C and O, so you can tell that they're different, right? Okay. If anyone's interested, the shape of water, it's actually called bent. It is a bent shape. Bent. And this is linear. What is the formula for water? H2O. What do we call that little number there at the bottom? That is a subscript. And what does a subscript tell us? The quantity of that atom. And if there is no subscript, that's just equal to 1. Carbon dioxide, what is the formula for carbon dioxide? CO2. There's no subscript for the C, so there's just one C. There's a 2 after the O, so there are 2 O's. So those are our covalent compounds. We also have ionic compounds, and they are made from the metals plus the nonmetals, and those give us our ionic compounds. And they actually don't exist as molecules. Okay, this might be new this year. Depends on who your teachers were in the last couple years. It exists as a three-dimensional crystal of alternating positive and negative, what are ionic compounds made? Don't think too hard. Ionic compounds are made of ions, okay? So they're not made of neutral atoms, they are made of positive and negative ions. It all adds up to 0, so you'll always have exactly the same number of positives as you do negatives. If you don't, it's unstable and it will wander around in nature and try and find like things to become stable with. Yeah, okay. And they will arrange themselves alternating because that is extremely stable. Negative will be surrounded by or positive ions, like at least if we're looking in 2 dimensions, yes. And your negative will be surrounded, or sorry, your positive will be surrounded by, find a different color here, 4 negative ions. Oh, that looked really bad. Okay, we just won't do that. Okay, we'll go like 1, 2, 3, 4. There we go. See, this little positive here is surrounded by negatives. This 3D crystal is called actually I should write an ionic crystal lattice. You're going to hear that word a lot. I love the crystal lattice. And I have a 3D model of a crystal lattice. So you can see there's the green, which is going to represent possibly chloride ions, negative Cl minus. And then there's the silver ones, which are the Na pluses, and they alternate. And in between them, what kind of force holds them together? It's a force between ions. And it's causing them to stick together. Once again, don't think too hard. Bonds. Yeah. Okay, so ionic bonds are the attractive force between the positive ion and the negative ion. When we write the formula for these ionic compounds, we use the simplest whole number ratio between the ions. Because can you imagine if we had a little teeny tiny grain of salt, we might have 300 sodiums and 300 chlorides. That would be so small you wouldn't be able to see it, okay? You might have another instance where you have 150 million sodiums and 150 million chlorides because your crystal is much bigger. Yes? So a salt crystal can be big with more ions, or it can be small with less ions. So the actual number will change of ions will depend on the size of the crystal. That's not helpful when we're trying to write a formula. you don't want to have to know the exact number every time. So we just use the simplest ratio. It's always going to be 1-to-1 for sodium chloride because those charges, exactly, they neutralize one another. Yeah. Okay, so in sodium chloride, there's always going to be 1 sodium for every 1 chloride ion. So the formula is NaCl. My bell gonna go in like 1 minute? Okay, hang on. That's page 48. You guys could do pages 50 and 51 for homework. There we go. And study for your quiz. If you are redoing the quiz, tomorrow is a good time to either come and get help or actually redo the quiz if you want to. I don't care if you got like 19 out of 20 and you want to redo it, that's fine. Okay, it might be a little bit silly, but it's all right, but you good? Are you good? You just look like you were thinking.
Oh, I have a test.
Oh, okay. Okay. So you're,
I'm thinking.
yeah. Okay, well, good luck. You won't need it. You'll be fine.
Oh, thank you.